Good morning, dear students. My name is Ferhan Mazher, and today is 9th April 2022. Right now, I am with the 11th Cambridge class, and we are preparing for the upcoming Cambridge exams. The subject we are studying is Physics of 5054. This is Cambridge O levels of physics, and today we have set our hearts to solve alternative to practical paper. We call it ATP, and we also call it paper 4. Today we have selected October, November 2015 4-1 paper. This paper 4 belongs from the zone 1, or you can say the variant 1. So let's start today's paper, and here comes the question paper. October, November 2015 4-1. The time allowed for this paper is 1 hour. Okay, so question number 1, when freely suspended, a bar magnet will come to rest pointing in a north-south direction. State which pole of the bar magnet points towards the geographic north of the Earth. Now you see, when you suspend a magnet, so it always align itself with the magnetic lines which are passing from that area, and the magnetic lines of the Earth, they are going towards the north pole of the Earth, the geographical north pole of the Earth. The magnetic lines of the Earth's magnet, they are always going towards the geographical north of the Earth. So when you will suspend a bar magnet with the help of a thread or with something else, that bar magnet, when suspended freely, will always align itself with the magnetic lines of the magnetic field of the Earth. So the north of the bar magnet will be pointing towards the geographic north of the Earth. So our answer, so let me show you my answer. So here we go, north pole of the bar magnet. That's the answer. Okay, so let's have a look at the marking scheme as well. So the marking scheme, North Pole. So here you can see the marking scheme showing up on your screen. Okay. Then he says, in order to find the direction of the geographic north, the magnet must be able to rotate freely in a horizontal plane. Describe a method of supporting the magnet in air so that it can rotate horizontally. You may use a diagram in your answer. So the method is very simple. Take a retort stand, and with the clamp of the retort stand, tie a thread, and tie the other end of that thread around the bar magnet. As you can see, I have made that diagram. So we have taken a retort stand, and with the clamp of the retort stand, we have tied a thread, and we have put a knot around the bar magnet. And now this bar magnet will be able to rotate freely in a horizontal plane. So you have to make this diagram, tie a thread around the bar magnet, and the other end of the thread is this is not in, it is supposed to be in, is held by clamp of the retort stand. Okay, so the spelling H is here, not here. Okay, so retort stand. I hope you understand. So let me show you the marking scheme of this question. It says simple means of suspension, 1 mark, and good practical details, for example, string stirrup at the center stated. Okay, so our answers are right. So let's move to the next part. One student suggests floating the magnet on water. Describe how the magnet can be supported on water so that it is able to rotate freely. You may use a diagram in your answer. So you see, styrofoam. Styrofoam is that white packing material you must have seen when you buy a refrigerator or an air conditioner. Around it, or LCD, so around it there is a packing material of the white color, and that is styrofoam. So take a piece of the styrofoam, and when you put the styrofoam on the water, it will float and it's very light. And put the bar magnet on the styrofoam, give it a little a little spin, and after some time it will keep on spinning in the water, and then it will align itself with the north-south direction of the earth. Okay, so let me show you my answer, and then we will check from there. So one student, okay, put a bar magnet on a piece of styrofoam. Now bar magnet will float and rotate freely in the water. So that is our answer. So you can see this diagram. I have shown water, and this is a piece of styrofoam, and the styrofoam has a bar magnet. Okay, so you can see this question. I hope you understand how to write this answer. And let's have a look at the marking scheme. Means of floating the magnet, for example, placed on the block of wood or polystyrene or foam object that floats on a float. Okay, so you can use a piece of wood also. You can use the piece of polystyrene. Polystyrene is the same material. Okay, so, and then we will go to the next question. The next question coming up on your screen is C part. He says, state and explain which of the methods in the B allows the magnet to stop rotating in the shortest time. So you can see the first method which we wrote, the bar magnet was rotating in the air, and in the second method, the bar magnet was on a styrofoam and it was rotating in the water. The friction, the air friction is less as compared to the friction of the water. So due to the larger water friction, the drag of the water, we hope that the styrofoam in floating in the water will stop rotating first as compared to the bar magnet which is rotating in the air, because the friction of the water or the drag of the water is more than the drag of the air or the friction of the air. So this is what we think. Okay, so let's have a look at. I have written this answer. Magnet in water will stop rotating first as compared to the magnet suspended in air, because the water has greater resistance than air. So let's look at the answer. We have this answer here. He says statement plus explanation. For example, water due to the more friction or the resistance. So our answer is right. Okay, so we are done with the question number 1 of the winter 2015 for one paper. So next question. The manufacturer of a super quilted paper towel claims that these white paper towels are more absorbent than another brand of yellow towels. A student designs an experiment to investigate the absorbency of the paper towels. The student pours 30 centimeter cube of water into a small shallow dish. He then cuts one paper towel into 16 identical small squares. One small square is immersed in the water and then lifted out using tongues as shown in the figure 2.1. Okay, so these tongs, and here you can see. So actually what they have done, they have taken a paper towel, which is of white color. There are two paper towels. One is of white color, the other one is yellow color. They are two different brands. So they have taken the white paper towel and they have cut it into 16 equal squares. They have cut it into 16, I think he said 16 small, yeah, 16 small squares. Okay. Now, and in the dish, they have poured 30 centimeter cube of water. So what they will do, they will take a paper piece of the square paper towel and they will dip it into the water and they will gently give it a jerk to drop the droplets of the water, and then they will put the water somewhere. Okay, that tissue paper somewhere. So they will keep on doing this process and they will count that how many pieces of the small squares of that white paper towel are used to completely wipe out that water, to completely dry that water from that dish. So he will note down how many small pieces of that tissue paper is used, are used, sorry. The student lifts the wet square above the water and gently shakes it twice before placing it in a beaker. He repeats the procedure using more squares until all of the water has been removed from the shallow dish. He records the number of squares needed to remove all of the water. So question number 2A, first part, suggests a reason why the student shakes each square of towel before placing them in the beaker. So you see, whenever you dip that square towel into the water, and then before you take it that tissue paper out, you shake that tongues because you want to shake off the water. You do not want this water to be dropped on the bench, and because we are checking for the absorbency of the paper, so that the drops which are falling, we do not want those drops to fall out of this dish, so we shake the tongues. Okay, so let me show you my answer and then we will see what's the shake off excess water from tissue and avoid drops of the water landing on the bench. That's my answer. Okay, so let's see what is the answer in the here. Remove excess water, water that has not been absorbed, shake off the drops, no drips on the bench, avoid spillage, remove surface water to do the same each time. Okay, so that was our answer. So this next part is, he says, second part of the A part. Explain why the student cuts the towel into small squares rather than using a whole towel. You see, if you use a whole towel, so you will not be able to quantify that how much towel has been used to completely dry 30 centimeter cube of water from the dish. To get a good to quantify how many paper has been used to completely wipe that water from that dish, we have cut it into small pieces. Because if you use a complete towel, you will not be able to understand or quantify or tell exactly how many. So to quantify them, we have to do this. Let me show you my written answer. Whole towel will absorb the water to quantify number of papers to dry the dish. Because if you use the whole towel, it will dry the dish, and you will not be able to tell exactly or very accurately that how much tissue was used to dry that water. So let us check the marking scheme. Whole towel would absorb all the water to obtain different values for different volumes, to get a large range of values, to get more results. Okay. Third part is suggest why the student does not cut the towel into very small squares. You see, if you cut them into very small squares, then it will take very long time to dry that 30 centimeter cube water in the dish, and the experiment will take a longer time to perform. It will take longer time to cut small squares and with small pieces to dry the water from the dish. So to cutting them, the towel into smaller pieces will take longer time. Plus, with those smaller pieces to dry the water, it will take longer time. So this is our answer. So let's have a look at the marking scheme or the mark. Anyone, he says anyone, takes too long to cut squares or do the experiment, only small amount of water removed each time, do not absorb enough water. So that is the answer, question number. So we are going to question number 2, and it's B part now. He says the student repeats the experiment using different volumes V of the water and measures the number N of the squares needed to remove all of the water from the dish. So figure 2.2 shows the student's results. So when there was 30 centimeter cubes, so 15 small squares were of that tissue were used. When the volume was 25, 10 were used. When were 20, then 10 were used, 15, 7 were used, 10, 5 were used, 5, 3 were used. So then he says on the figure 2.3, plot the graph of N on the y-axis against V on the x-axis. Start your axis from the origin. Draw the straight line of the best fit. So here is that figure, and we have to label its axis, and we also have to plot these points, and then we have to draw the straight line of the best fit. So the n value will be on the y-axis, and this v value will be on the x-axis. So this is the question. Okay, so let's go. Okay, so you can see first of all what I have done here. The V, the volume of the water, is represented on the x-axis. So 5, 10, 15, 20, 25, 30, 35. Here the number of the towels, they are represented. So this is 5, 10, 15, and 20. So this will be 2.5, this will be 7.5, that's 12.5, that's 17.5. So we have to plot and that, and let me show you that we have that table. That's table. Okay, at 30 we will put a dot of 15, at 25 we'll put a dot of 10, at 20 put a dot of 10, at 15 put a dot of 7, and this is x value, this is y value, 10 comma 5, 5 comma 3. So I will plot these points. I have, you can see that I have plotted those points here. Okay, so I have plotted those points. These are those points. This point, 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 this point. Okay. So then I will have to draw the line of best fit. And before going to that, you have to label the axis. It's very important. You can see I have labeled the axis. You see, I have joined these points. Okay. These points, this is the line of best fit. I have left this point because at 20 the value was 10, at 25 the value was 10. So this number, this dot is out of the pattern, so I left it. So join just them. So let's go to the next question. He says, we have drawn that graph. Determine the gradient of your line, show your working. The finding the gradient of the line is very simple. You see, you can take any 2 points, like for example, this is 5 comma, I think something, and take this point for example, and note their coordinates, and then apply the. Okay, so I have taken 5 comma 2 and 35 comma 17.5. The gradient formula is y2 minus y1 divided by x2 minus x1, and it will be 17.5 minus 2 divided by 35 minus 5, so it will be 15.50 divided by 30, and the answer will be 0.52. So your gradient is 0.52 approximately. So let's have a look at the marking scheme. So our answer is this. They say this is their answer. Plot correctly. Okay. They say the gradient will be from 0.59 and plus minus 0.02. So our answer is almost in the range. Our answer is 0.52. They say 0.59 plus minus 0.02. Okay. Approximately our answer is right. Okay, you can draw a better line of best fit, and then you will have a closer answer to this. Okay, so then the next question they are asking is, okay, they say suggest a reason why the student decides to repeat the reading for V equals to 25 centimeter cube. You see the number of papers used for squares used to dry 25 centimeter cube are 10. The number of papers used to dry 20 centimeter cube are also 10. So when we plotted those points, the point for the V25 was this point that was out of the pattern, away out of the pattern. So we will left it. So that's why we do this again. So let me show you. V equals to 25 centimeter cube. Its point does not fit with the pattern of the other points on the graph. Okay, so we will repeat it. Then let me check. Furthest point from line, anomalous point does not fit on the line, does not fit the pattern. So we are going to the next part. The next part is the paper towel was cut into 16 identical small squares. Use your graph to find the volume of the water that can be absorbed by a whole paper towel. So there are, so you have used the 16, you know, what they're saying is, we have used how many squares? 16. So 16 is here. From here, come to the graph and check what is the reading here. Okay, so from 16 we'll come to the graph here somewhere, and below this graph, check what is the reading, is 32 something. Okay, so if you are doing it on a what you say, oh, you have the hard copy of this paper, then you can do this. Otherwise, you have to be. The paper towel was cut into 16. Okay, so from the graph, I can tell 31.5 centimeter cube of water. 31.5 means 32. So let's have a look. 32 plus 0.5 centimeter cube. So our answer is perfect. Then we have the C part. He says the student repeats the experiment using the other brand of the yellow towel. So now they're talking about another brand of the towel. The graph of N against V centimeter cube for the yellow towel is steeper. So then the graph for the white towel. State and explain whether the white or the yellow paper towels are more absorbent. So what they're saying is, let me show you the meaning of that. They say the graph is more steeper. Let me say, for example, okay, so let's take, they want is that the graph is more steeper. Okay, so this graph, do you know, is more steeper, its slope is more. So if you look at, for example, if you have, let's say this water, 10 centimeter cube. So you will require, I think, 4 paper squares of the white one. But for the yellow one, for the same water, you have to use approximately, I think, 10. So you see, the white number of papers are used less. So to completely wipe the 10 centimeter cube of water, when you use white, you will need only 4 squares, and when you use yellow one, you will require 10. So it means the white ones are the better ones. Okay, I hope you understand the meaning. Okay. No. Okay. So our thing, yeah, let me show you my answer. White towels are more absorbent. Less squares are used to absorb water as compared to the yellow towels. So if you have the same amount of the water, the number of towels, white towels used will be less. And to wipe the same amount of water, if you use the yellow ones, more number of paper towels are used. So the white one are better absorber. They have the better absorbency. Okay, so let's have a look at the marking scheme. He said white towels plus explanation. For example, more squares needed for yellow towel. Steeper gradient means more towel needed per unit volume. Okay, so you can write this one also. Okay, so we are going to the D part. He says the yellow paper towels are smaller than the white paper towels. Explain whether the student should either cut each yellow towel into 16 small squares, or cut the yellow towel into squares the same size as the squares of the white. If you want to have a good and a fair comparison, because the yellow ones in size they are smaller. So if you want to have a fair comparison, because you are depending upon the number of squares of the used, square means the name square. And so for a good comparison, it is must that both the yellow and the red, when you make their small squares, the squares of the white and the squares of the yellow, they should have the same size. So I think B is the right option, sir. Let me show you for a fair comparison. Students should cut the yellow towel into squares the same size as the squares of the white towel to have a fair comparison. So that is my answer. Let's have a look. B, to make a fair comparison, experiment results of the material to keep the same conditions. Number does not matter. It is the absorbency that does matter. Okay, so we are done. So now we are going to the next question. The next question coming up on your screen is question number 3. He said the student uses a pinhole camera to produce an image. The pinhole camera consists of a light-proof box with a small pinhole on one side and a very thin paper screen on the opposite side, as shown in the figure 3.1. The student points the pinhole of the camera towards a bright window, as shown in the figure 3.2. So here you have the window, here is the small, here will be the screen, a transparent screen, and from here you are watching. So light enters the camera through the pinhole and produces an image on the thin paper screen. The student can use the screen, see the screen through the this thin paper. The student observes the image of the window on the screen. He says, on the figure 3.2, they are talking about this figure. Draw ray of light from the top A of the window through the pinhole to the screen. Draw a ray of light from the bottom B of the window and through the pinhole to the screen. Measure the angle between the two rays of the light. So the method is very simple. You see, this is that diagram. So let me take out the snipping tools. Let me show you how we can do that. Okay, so just copy it. Let's bring it in the paint. Okay, so I just want to show you what we have done. So I will take a straight line. Okay, so we will start from the A. Okay, and the other line will start from the B. Like this. And then you have to measure the angle. And what is that angle? This angle. Okay, you have to measure this angle, or you want to measure this angle. Okay, the angle between these two lines. This is the question. Very simple. So let me show you. I have done also. And here we go. So that's the diagram. This second line is by mistake. Okay, so just don't bother about it. Then if you measure the angle between them, that will be 17 degrees. So let me check the answer from the marking scheme. Ray from A to the screen through the pinhole, from the B to the screen through pinhole, and 17 plus minus 2 degrees. So our answers are perfect. Then their question is, he says, explain how you measure the angle as accurately as possible. You see, whenever you measure the angle, the lines should be long enough so that they can reach the graduation of the protector, and you should avoid the parallax error. The line should be very, thin to get a better answer. Let me show you my answers. Both rays of light should be long so they reach the graduations of the protector. You know the numbers written on the protector. Sometimes when we try to measure the angles, the arms of the angle, they do not reach the graduation. So in that case, you have to make an estimation. But if you make the arms of that angle, every angle has two arms. So they should be long enough that when you put them in under a protector, so their lines should reach the graduation. So then you will be able to read them accurately. So let me check the marking scheme. What the marking scheme has to use longer lines, for example, use of the rays on the left hand side of the pinhole, extend rays on the right, measure the angle from both the ray. You can also measure the angle from both the sides. What do I mean by both the sides? Let me show you. Measure the angle here and also measure the angle here. The both the angles will be same. They are vertically opposite angle. So our answers is right. Okay, so we are moving to the next question. The next question number 3. Explain why the image of the window on the screen is inverted. You see the A was on the top. In the image, it came to the bottom. The B was at the bottom of the object. But when the image formed, it was on the top. So that's why it's inverted. Another reason is because the image formed is real, and that's why it's inverted. Okay, so that is what I think. Okay, so let's have a look at the marking. My answer. Image is real. Ray started from A on the screen is at the bottom, and ray started from B is at the top on the screen. So that's why the image is inverted. So let's have a look at the marking scheme, what the marking scheme has to say. Ray from the A forms bottom of the image, or with B images are real rays of light cross or intersect rays of light meet at the pinhole before the screen. Okay. Then the last part of this question is, he says, here we go. A pinhole allows only a small amount of light into the camera so that the image of the window is not very bright. The student decides to make the pinhole larger to allow more light into the camera, as shown in the figure 3.3. The image formed on the paper screen is now blurred. On the figure 3.3, draw two rays from the A that enter the camera. Use your diagram to explain why the image is blurred. You see, I have drawn this. You see, when I started two rays, one ray started from the A and touched the upper edge here, and one ray started from the A and touched the lower end of that hole. So the A is coming on two places here and here. The same way, when you started the ray from the B, one ray touched this upper side of this hole, and one ray touched the lower side of this hole. So the image will be here and here also. So here on the screen, two images of A and B will be formed, and that's why when you will look at that image, because the image of the AB, there will be two images of AB. So the image you see will be blurred. It says more than one image is formed of the point A. That's why its image will be blurred. I hope you understand. Let's have a look at the marking scheme. He says light from the A spread out, diverge on the screen, form more than one image. Rays form from A do not meet at a point on the screen. It's going to 2 points. So that was the question number 3. So let's go to question number 4. A student measures the volume of glass used to make a small beaker. The figure 4.1 shows a full-size diagram of the beaker. On the figure 4.1, mark and label the external diameter D of the beaker. External diameter starts from this side to the outer this side. And then the internal depth is from here till here. And then he says the thickness of the thickness of glass is from here till here. So we have to mark these points and show them. And then he says, by taking measurements from the figure 4.1, find the values of the D, H, and T. Give your answer to the nearest millimeter. Okay, so very simple. Let me reduce the size so you can see the whole question together. So here is that question. So, okay. So let me show you. Okay, so here you can see the external diameter from the external wall here to the external wall here. That's the external diameter. The internal depth will be from to the brink and from the bottom. That's the internal high depth, and this is the thickness of the glass from here till here. And I have labeled it. So the reading on the D will be 46 millimeter and 48 millimeter and 2 millimeter. That I have measured with the help of the scale. So let me check. 46, 48, 2. I hope you can understand this. So we are going to the next question, and he says, the question is that an approximate value for the volume V of the glass used to make the beaker is given by the relationship. So V is equals to pi dt H plus D by 4. Using your values from the A second part, calculate the V, showing your working, and give your answer to two significant figures. Okay. So let me show you my written answer. Here we go. So just pi, D value is 46, T value is 2, H value is 48 plus 46 by 4. Just enter these values in the calculator, you will get 17199. So approximately 1700 in two significant figures. So that's what the answer is. I'm not sure. Yeah, 17000 centimeter cube, millimeter cube, sorry. Okay, so our answers are right. Then the last part is, it says suggest suitable measuring instruments to measure T and the H accurately of an actual beaker. T is the thickness, and thickness which is up to 2 millimeter. You can measure it with the help of a micrometer. H, which is the internal depth, that can be measured with the vernier caliper. For internal depths, we use vernier caliper. So let me show you micrometer and vernier caliper. So that is our answer. So the paper is over. So my dear students, today we have done uh, October, November 2015 for one papers. But before going to end this, let's have a look at the marking scheme. He says 1 year micrometer caliper, depth gauge, ruler with no dead space, both ends. Okay. So okay. So, my dear students, today we have done October, November 2015 for one paper. This was alternative to practical ATP. We call it paper 4, and this paper belongs from the zone 1. I have tried my best to explain you the concepts, and you can see I have written the answers, and I was also checking the marking scheme, because sometimes, the human, we can make error, mathematical error, sometimes calculation error. So I always advise you, whenever you solve a paper, it's my advice. Every day when I make a video, I tell you this advice. I write the answer, your teacher write the answer, the red spot writes the answer, you write the answer, your friends write the answer. Always confirm those answers. Always compare those answers with the marking scheme issued by the Cambridge. It's a very important habit you should have. So, my dear students, thank you very much. And I also want to especially thanks all my students around the world who are sending me very appreciating comments. Your comments means a lot to me. So thank you very much. Have a good day. God bless you all.